Okay. So let's start by finding a position vector. Let's pick A. So we'll start here at A. We want to find this force vector, and then we'll do B, and then we'll do C. Now we know the magnitude in each of them is 60 pounds. So I just need to find the position vector here. Divide it by its magnitude. I can find a unit vector and then multiply it by 60. Okay, so let's start with what's the position vector from O to A. So I'm starting here at O and I'm going to A. So in the x direction, what am I going? Well, if this whole angle is 120 and it's 120 off the y-axis, then what's this angle right here? 30. So the x component should be what? The cosine of 30. And then what's the radius of the whole chandelier? 4. So it should be 4 feet times the cosine of 30 degrees. That will give me the x component, and that's positive. The y component is going to be positive or negative? Negative. So we'll say minus, and that'll also be 4 feet, and that'll be the sine of 30 degrees. You guys see that? Oh, I left out my... I'll just do them in different colors to denote that those are vectors. And then finally, my z component is what? All the z components from O down to this plane are 6 feet. So this will be minus 6, and that'll be in the k direction. Is that okay with everybody? So what will be the magnitude of that vector? What is the magnitude of that? I probably should compute that. Maybe I'll just leave it like that. What's cosine of 30 is 0.866, right? What's that? Somebody compute that for me. Should be something like 3 point something? 3.46. And that's I. And then this is going to be minus 2, right? J. And then minus 6k. You guys get that? So what's the magnitude of that? 6 squared plus 2 squared plus 3.46 squared. What do you get? 52? Too big. In fact, take the square root of it. 7 point what? 7.2. 7.2. And that will be in feet. You guys get the same answers? So I guess I can go ahead and calculate my unit vector from OA, right? What would it be? Position vector divided by dimension, right? So what is it? I could write it this way, 3.46 minus 2 minus 6, that whole thing divided by 7.2. And this is I, J, K. So what's that come out to be? What's the first term?
0.48.
0.48? What's the second term?
0.28.
Great. And the last term?
0.83.
0.3?
0.83.
Oh, 83. Okay, great. Okay? So what will be the force vector then? What is the force vector? We're doing A. So what would that be? All the forces in the cables are 60, so I'd take 60 times the unit vector. So somebody ring those out. So what's 60 times 0.48? I'm sorry, say again?
28.8.
28.8. Okay, great. That sounds reasonable. What's the J component?
16.6.
16.6. And then the last component?
49.8.
49.8. Hopefully we did that right. Anybody see any problems? You can see there's a lot of room for mistakes. That's too bad. Give me just a second. Check something before we move on. Don't want to start you down a wrong path. Okay, that looks good to me. A lot of work. I guess we have to do it 2 more times. So I guess we should get started. Maybe after I've done that, maybe some of these operations could be lumped together. For example, when I find my position vector, I can hold off this calculation to the end and then multiply everything by 60. I can write one expression with a lot of calculations instead of breaking it down by pieces. So let's try that. So now that we see the pieces, let's try to find the value for B, which is this one here in the back. So I know starting off that it's going to have a magnitude of 60 pounds. And then I want to write in the position vector, and then I'll divide it by the position vector length. So what is the position vector going from O to B? I don't know if I can draw this well, but if I extend this x-axis out the back, you can see that the y value, from the y-axis, you go 180 degrees. So again, it's hard to see, but this angle here will also be 30. You see that? So my x component now will be the same as before. It'll be the cosine of 30 times 4, but it'll be negative this time. So I'll go ahead and write it that way. Negative 4 feet cosine 30. Now what's our j component?
Negative sine 30 times 4.
Right, it's the same as before. So minus 4 times sine 30. And then fortunately all these have the same z component, right? Minus 6, and that's going to be in the k direction. Now to convert this, which is the position vector from O to B, I'm going to divide it by the magnitude. So you are going to have to compute the magnitude. Now if you look at it, we've already done it. Because when these terms are the same, the signs are different, but when you square them, the signs go away. So we should get the same 7.2 magnitude. You see that? So I can just come out here and divide this by 7.2 feet. So this, in a sense, this is my position vector from O to B. Position vector divided by magnitude, and then multiplied by this should give me the final form of FB. So now I just have to let you guys do all that calculation for me. So the X term will be the same as it was before, except it'll be negative. So this should be what? Hopefully it'll come out to be 28.8, but negative 28.8. Why don't somebody check that for me? And I'm hoping that the Y component will come out to also be 16.6 as before. And that should be in the J. And then our K component has the same values as before, and it's also negative 49.8. Is the calculations working out? So these are all negative. It's getting a little messy here. So there's my force in the B direction, and there's my force into A. All right. Unfortunately for us, we have to do this one more time. But I think this one will be the easiest one to do. The force in the C direction, or from O to C. Now what's nice about this is you'll notice the way it's given is this force is in the YZ plane. There is no X component. And we know that it's 4 in this direction and 6 in this direction. So we should be able to calculate angles that we need, or just the dimension. So in the X direction, there is no component. The position vector in the Y direction will be what? If you go from O to C, it moves 4. So our position vector, we have the same magnitude as before. So our position vector will just be 4 in the J direction, and then it will be minus 6 in the K direction. Everybody see that? Now what's the magnitude of that force? What's the magnitude of that position vector? 4 squared plus 36 squared. That doesn't come out to anything nice and neat, does it?
7.2.
7.2. Well, that's nice, but that checks. So now do the final multiplication. So what is the final value for the force at C? So 60 times 4 divided by 7.2. Looks like it's going to be 30 something. 33.3. Okay, and then go ahead and do the last one, the 6.
50.
50? Okay. And that will be in the K direction. I did make one mistake. I forgot to include that all these have the units of pounds. I'll go back and throw a parentheses around them. We need to make sure we keep our units. So we've been working pretty steadily here for quite a few minutes. And now we have our 3 vectors. So all we need to do is what? What's next?
Find angles.
Right. Well, first we can just go ahead and find the the force, right? We can add up the components and find the force vector. So what would it be? So the resultant force, say F sub R. So we add up the X components. I've got 28.8 minus 28.8 and nothing. So those cancel out. No I component, right? I've got minus 16.6, minus 16.6, plus 33.3, that's pretty close to 0. And then I've got minus 49.8, minus 49.8, minus 50. That's all pretty close. It looks like all I'm left with is about 149.6, something like that.
Yeah.
And that would be in the K direction, and that would have units of pounds. So there's our resultant force. So what's alpha going to be? Alpha, beta, and gamma. Remember those? So alpha is going to be the arc cosine of what? The x component, which is 0, right? So what is the cosine of 0? The arc cosine is 0. 90, right? Beta is the arc cosine of the y component divided by the magnitude, but there is no y component. So that's also 0. So that's, again, 90. Finally, gamma is the arc cosine of the z component. Oh, there we go. We finally have something. So that's minus 149.6 divided by the magnitude, which is 149.6. And what does that give you? What's the arc cosine of minus 1? I think it's 180. Any questions about that? Actually, that was kind of a deceiving problem because, first of all, you had to do a tremendous amount of work to get to where you wanted to be, but it all worked out at the end because it ran out pretty quick. But again, you can see there's multiple places to make errors, so take your time and work through these as slowly as you can.
So it was negative 149.6 over, that was the...
Well, you have a vector with just one component, so what's the magnitude of the vector?
yeah, it's going to be that.
That's positive.
But the magnitude of the vector, you square it, and take the square root, so it's a positive quantity. So the component is negative, but the magnitude is positive.
So like on tests and stuff like that, if we have like numbers that are pretty close, within like 2 or 3 decimals will cancel each other out, we can just throw them out?
Well, the same thing is true here. If you get to this point and it's not 0, it's 0.002, you're going to get pretty close to that.
Okay.
That's close.
I just want to make sure it's safe to just throw them out if it's close. To an extent.
Well, one thing we should have noticed in this one is that we've got 4 times the sine of cosine of 30 and minus 4 times. So really, you could move the decimal place here or there, but if you just look at it, they just cancel out. That was lucky. It's just numbers, and if you do get a little bit in, just bring along. It'll all be okay. I mean, if you don't get 180, you got 179.8. Good enough for me. All right, thanks, guys. See you. I'll post some homework in the next hour or so, and we'll move from there. Why don't you guys go ahead and start reading through